Next example of kernel of T and range of T. Find basis and dimension of kernel of T and range of T, that is kernel of T and RT. If T is function from R5 to R raised to 4, defined as T of x1, x2, x3, x4, x5. This is 5 tuple, that is the domain is R5. And what is the its image x1 plus 4x2 plus 5x3 plus 9x5 comma 3x1 minus 2x2 plus x3 minus x5 comma minus x1 minus x3 minus x5 comma 2x1 3x2 plus 5x3 plus x4 plus 8x5, and this is 4 tuple. This is the 4 tuple, and so it is the element of R raised to 4. So this is the function from R raised to 5 to R raised to 4. And then now we write the linear transformation in the form of matrix, the definition of linear transformation. So T x1, y1, x1, x2, x3, x4, x5 as a column matrix is equal to, write this as first column x1 plus 4x2 plus 5x3 plus 9x5, the second component as second column, third component as third column, third row, not column, and the fourth column as a fourth row. Okay, so write the matrix in the matrix form. This is linear transformation in matrix form in order to find the standard matrix. So write this as a coefficient matrix A, and this is the X, capital X. What is X? This is x1, x2, x3, x5. So right here x1, x2, x3, x5, and then coefficient of x1 in the first row is r what? X1 is 1, x2 is 4, x3, x2, x3 is 5, x there is no x4 term, so its coefficient is 0, x5 is 9. Similarly, 3 minus 2, that is 1, then x4 coefficient is 0 and x5 minus 1. Then minus 1, 0, the coefficient of x2 is 0, x3 is minus 1, x4 is 0 and x5 is minus 1. And then coefficient of x1, x2, x3, x4, 2, 3, 5, 1, 8. And so this linear transformation expressed in the form Tx is equal to Ax. And what is A? A is this matrix and is called standard matrix for T. Okay, or this is the multiplication by A. The linear transformation T is multiplication by A. And now we have to find the range, dimension and basis of kernel of T and range of T. And we know that the kernel of T is the null space of the matrix A, and the null space of the matrix A is the solution space of the system Ax is equal to 0. Now in order to find kernel of T, we have to find the solution space of system Ax is equal to 0. And so consider the system Ax is equal to 0. So A, write A, X as x1, x2, x3, x5 is equal to 0, 0, 0. This is the column matrix of order containing 4 rows. And then multiply these two matrices. We have x1 plus 4x2 plus 5x3 plus 9x5 is equal to, then second row is this 3x1 minus 2x2 plus x3 minus x5. Then third row, apply the third row on first column, then third row on this column. We have this, and is equal to 0, 0, 0. And then compare the LHS and RHS. We have this system. So again, we have the same element. This is equal to 0. This is equal to 0. This is equal to 0, and this is equal to 0. So we have this same equations is equal to 0, and we have to solve this system. We have to solve this system. So we have to solve this system by using Gauss elimination method. So form the augmented matrix. So the matrix of coefficient, that is A matrix, and the matrix of constant is 0, 0, 0, 0. Okay, and then we have to reduce this matrix to echelon form or row echelon form. So in order to that, we have to reduce this element to 1, but it is 1. So reduce this 3 element to 0. So operation are R2 minus 3R1, R3 plus R1, and R4 minus 2R1. So by using this one, we have to reduce this 3 element to 0. So after these 3 operation, we have this matrix. Okay, so here is we have minus 14, minus 14, minus 28, 4, 4, 8, minus 5, minus 5, minus 10. Here is 1, 1. Okay, 0 and 1, as it is 1, here write 1. And then the operation is minus 1 by 14 R2. We have to reduce this element to 1. So we have this as the second row, the remaining rows as it is. Then we have to reduce this 4 and minus 5 to 0. So operation is R3 minus 4R2 and R5 plus 5R2. So we have the first row, second row as it is, the third row is 0, 0, 0, and this one is as it is, 0, 0. Now we have to reduce this element to 1, this element to 1, but it is not 1. So this row is 0. So we alter these two, third row and fourth row, interchange the third row and fourth row. So R3, 4. And so we have one, the first row as it is, second row as it is, and last row become third row. And this is an echelon form. This is an row echelon form, or say echelon form. And so rewrite the equation now. Rewrite the equation. So first equation is x1 plus 4x2 plus 5x3 plus 9x5 is equal to 0. The next second equation x2 plus x3 plus 2x5 is equal to 0. And the last equation x4 is equal to 0. And so here we have, there are 3 equations in this system. There are 3 equations and 5 unknowns. Unknowns are x1, x2, x3, x4, x5. And so assign 5 minus 3, that is equal to 2 unknowns. So we assign x, we have already x4 as 0. So we assign the remaining unknowns. So we assign x3 and x5. Suppose x3 is t and x5 is s. So assign 2 unknown. So what are that? Either x1, x2, x1, x2, x3 or x5. So we assign x3 and x2, x3 and x5. Out of these 3 we have to assign 2. So we assign x3 as t and x5 as s. So where t and s are any element of R. And therefore x2 is equal to minus x3 minus 2x5, that is minus t minus 2s. And x1 is from this equation number 1. 1 implies x1 is equal to minus 4x2 minus 5x3 minus 9x5. Substitute the value of x2, x3, x5. We have x1 as minus t minus s. And therefore the solution in the matrix form, x1, x2, x3, x5, solution of the system. So x1 is minus t minus s, x2 is minus t minus 2s, x3 is t, x4 is 0 from this equation, x4 is 0, and x5 is s. And then we can write this as in the addition of these two column matrix, t minus 1, 1, 0, 0. And then coefficient of es are what? Minus 1, minus 2, 0, 0, 1. And therefore the basis for solution space of the system Ax is equal to 0. Actually we have to write the basis for kernel of t, but basis of for solution space of the system Ax is equal to 0 is the basis for null space of A and is the basis for kernel of T, and is equal to the set contains 2 elements, minus 1, 1, 0, 0. That is this as, write this as a first vector and this as the second vector, minus 1, minus 2, 0, 0, 1. So this is the basis for kernel of T. Actually this is the basis for solution space of the system, and it is a basis for kernel of T. And therefore dimension of kernel of T, this set contains 2 vectors, and therefore dimension of kernel of T is 2, and therefore nullity of T is 2, because the dimension of kernel of T is equal to nullity of the T. And this set basis for kernel of T contains 2 vectors, and therefore nullity of T is 2. Now we have to find the range of T. Range of T is what? Is RT, denoted by RT, and it is column space of A. So how we can find the basis and dimension of column space of A? We have to reduce the matrix A to reduced row echelon form. So consider the matrix A. A is this matrix. Okay, consider this matrix A, and we have to reduce the matrix to reduced row echelon form. First we reduce the matrix to row echelon form by using the previous part. We have directly right here, after the by previous part we have the echelon form of this matrix as this matrix. This is the row echelon form. Now we have to reduce this matrix to reduced row echelon form in order to find the basis for column space of A. And how we can write, how we can reduce the matrix row echelon form to reduced row echelon form? So the elements, the columns that contains leading one, we have to reduce the remaining element of that columns are equal to 0. So if you observe the first column, there are the three columns, this first column, second column, and fourth column. These three columns contains leading one. So the remaining element of the first column are 0, except the 1, all remaining are 0. So in the fourth column also this is leading 1 and the remaining element are 0. But in the second column this is 1, but the remaining element are not equal to 0. This is not equal to 0. So we have to reduce this 4 to 0. So the operation is R1 minus 4R2. And then we have the element 0 at this place, but then R1 minus 4R2. So 5 minus 4 is 1. Then 0, 0 as it is. 9 minus 8 is 1. So after this calculation, we have the reduced row echelon form. So the column number 1 and 3, 2 and 4, these three columns contains leading ones, and therefore these three columns form the basis for this matrix. Form the basis for column space of this matrix. Okay, but we have to write the basis for column space of the matrix A. So corresponding columns 1 to 4 contains leading ones. Okay, and so corresponding columns number 1 to 4 in A form the basis for column space of A. This sentence is to understand how we can write the basis for column space of A. So how we can write basis for column space of A is the set of the vectors of the columns. First column as the first vector 1 3 minus 1 2, the second column as the second vector, and the fourth column of the A as the fourth column of A. So what is the fourth column? 0 0 0 1. This is not the fourth column. This is first, second, and we have to write the fourth column. This is not fourth column actually. 0 0 1. So correction is at this place. Write this element as 0 0 1. Don't write this element. 1, 2 and fourth column. Fourth column is not this. 0 0 0 1. So right here. Correction is here. 0 0 1. And therefore this is the basis for column space of A. So how you can obtain the basis for column space of A? Reduce the matrix A to reduced row echelon form. Note the columns that contains leading ones, and the corresponding columns in A forms the basis for column space of A. So basis for column space of A is the set of vectors, three vectors. The first column as first vector, the second column as second vector, and the fourth column. So right here 0 0 0 1 instead of this element. And so again, basis for kernel of T. This is the basis for column space of A, and the basis for, because the column space of A and range of T, that is RT, both are same, and so basis for RT or range of T is what? Write the same basis as the basis of RT. That is that, right? This first element, second element, and correction is here 0 0 0 1. Okay, and this set contains, this basis contains three vectors, and so dimension of RT is 3, and therefore rank of T is 3, because the dimension of RT is called rank of T, and so rank of T is 3. So the question is what? Find the basis and dimension of kernel of T and range of T, and also the question is what? Find rank T and nullity T. So we have to find if the rank of T, nullity of T, then we have to find the basis for column space and basis for system solution space, system Ax is equal to 0. Okay, so we can find the rank of T or basis for RT in a different way. So RT is what? Column space of A, and is equal to row space of A transpose. That is, row space of A transpose is equal to column space of A. So how can write A transpose? We can write obtain A transpose as, write first row as a first column. That is, interchange the rows and column. Then write second row as a second column. And then write third row of A as a third column. And then write last row as a fourth column. 2 3 5 1 8. 2 3 4 2 3 5 1 8. That is, write first row as first column, second row as second column, third row as third column, and the fourth row of the matrix A as a fourth column of A transpose. So this is A transpose. Interchange the rows and column. So we have, this is the A transpose, and now we have to find the row space of A transpose. So this is the matrix, and we have to find its row space. And how we can find the row space or basis for row space? Yeah, reduce this matrix to echelon form, row echelon form or echelon form. So first reduce this matrix to echelon form. So it is 1. So we have to reduce this 3 element to 0, 4, 5 and 9. So these are the operation: R2 minus 4 R1, R3 minus 5 R1 and R5 minus 9 R1. We have this matrix. Then we have to reduce this minus 14 to 1. So 1 minus 1 by 14 R2 is the operation. We have 1. Here we have minus 4 by 40, 5 by 40. Okay, and the remaining rows as it is. Now we have to reduce this minus 14 and minus 28 to 0. So operation is R3 plus 14 R2 and R5 plus 28 R2. So by using this operation, we have this matrix 0 0 1 is the second row, third row at 0 0 0 row, fourth row 0 0 1 0 0 0. Okay, and then interchange the third row and fourth row. We have this is an row echelon form of this matrix A transpose, and therefore basis for row space of A transpose. What is the basis for row space of any matrix? Is the set of non-zero rows in its echelon form. So write the first non-zero row as a first vector, comma the second non-zero row as the second vector, and the third non-zero row as the third vector 0 0 1. So there are 3 non-zero rows. So form the three vectors of this basis as these 3 non-zero rows, and this is the basis for row space of A transpose. And row space of A transpose is column space of A, and therefore basis for column space of A is what? Write these vectors as a column vector. So 1 3 minus 1 1 2 0 1 minus 2 by 7 5 by 40. This minus 4 by 14 means minus 2 by 7 after calculation, and 0 0 0 1. So this is basis for RT. So this echelon form of any matrix is different answer. We have the different answer. This is not unique. This reduced row echelon form is not unique, or row echelon form is not unique, and therefore the elements in basis for column space or row space are not unique, but the number of elements in this set are 3, and therefore this answer is unique. That is, the number of elements in the RT, basis of RT is 3. This answer is unique. This answer is not different. That is, everyone has the 3 vectors in basis of RT. Everyone has the 3 vectors in basis of RT, but these vectors may be different other than this. Okay, so it's depend on your calculation. Similarly, here this is the basis for row space of A transpose, and this is the row echelon form. This echelon form is not it is not unique. This answer is not unique. It's depend on your calculation, but the number of elements in the basis of row space of A transpose is 3, and this answer is unique. That is, everyone has the 3 vectors in the basis of row space of A transpose, and the basis row space of A transpose is nothing but the column space of A, and therefore basis for column space of A is what? But just write these vectors as a column vectors. Okay, so this is the basis for RT, because basis column space of A and RT both are same, and so this is the basis for RT. This set is the basis for RT, and therefore dimension of kernel of T, dimension of range of T is 3, because this set contains 3 elements, and therefore rank of T is 3. So we can find rank of T by using either this procedure, that is reduce the matrix A to echelon, reduce to echelon form, then note the columns that contains leading one, and the corresponding columns in A form the basis for column space of A. Write A transpose, and then find the basis for row space of A transpose, and it is a basis for column space of A. Okay, and that is the basis for kernel of T. So we will find the basis for kernel of T, basis for range of T in 2 different methods. So either use this method or use this method. Okay, so these are some problems for homework. Find a standard matrix for T, and hence use it to find rank and nullity of T. That is, first write this example is already this is the answer of this example number 2. B answer of B is this. Okay, so I have to write where to solve this equation, problem number 1 first. So T is from X, Y, Z, W. Instead of X1, X2, X3, X4, that is the notation X, Y, Z, W. That is, this is R square. This is the element of R raised to 4. X, Y, Z, W is element of R raised to 4. And so domain of R, T is R raised to 4. To this X minus 2Y plus Z plus 3W, comma, 2X plus Y plus 4W, comma, this minus X minus 3Y plus Z minus W, comma, 3X plus 3Y plus Z plus 7W. And this is 4 tuple. The image is 4 tuple. And so T is function from R raised to 4 to R raised to 4. Okay. So we have to find the its standard matrix. So apply this procedure to obtain the standard matrix. Write the definition of formula of that linear transformation in the form of matrix. Then write A, and then that is the standard matrix. And then find basis and dimension of kernel of T and range of T. We have the rank of T and nullity of T. So find rank and nullity of T. So first write the find the standard matrix of for T, and then find the rank and nullity. That is, find the basis for range of T and basis for kernel of T by using the previous procedure. Okay. So the answer is given. This is the standard matrix, and the rank of T is 3 and nullity of T is 1. So if you observe the rank in the previous, and that is example number 2, this is from R5 to R4. This is the example. And so this is the standard matrix. And so rank of T is 3 and nullity of the linear transformation T is 2. And if you observe rank plus nullity is equal to, for the matrix, rank plus nullity is equal to what is the theorem for rank nullity? Theorem for matrix, the rank of T plus rank of A plus nullity of A is equal to number of columns in that matrix. And so how many columns in this matrix, standard matrix? There are 1, 2, 3, 4 columns. And this is depend on what? This is depend on if this is the matrix, this is the linear transformation from R4 to R4. This is R5 to R4. This second linear transformation is from R5 to R4. And so how many columns in this matrix, standard matrix of linear transformation T? 1, 2, 3, 4, 5. So the number of columns depend on the what is the domain. So in this second problem, domain is R5 and its dimension is 5. And so the rank nullity theorem for linear transformation is what? Rank of T plus nullity of T is equal to dimension of domain. So in the first problem, dimension is 4 because T is linear transformation from R raised to 4 to R raised to 4. Domain is R raised to 4. And in the second problem, domain is R raised to 5 is the domain of the linear transformation. This is function from R raised to 5 to R raised to 4. So domain is R raised to 5. And so the rank of T plus nullity of T is equal to 5. The domain, the dimension of domain is 5. So this is rank nullity theorem. So same example, find the rank and nullity of this linear transformation T. I can write the matrix in the linear transformation, this transformation in the matrix form, then find the standard matrix, and then find the rank and nullity of the linear transformation T. Similarly, find basis and dimension of kernel of T and range of T. So what is the kernel of T and what is the range of T? We know that. First find the standard matrix and then find the basis and dimension of kernel of T and range of T. Similarly, here the example, let T from R3 to R square be linear transformation such that T of 1, 0, 0, T of 0, 1, 0 and T of 0, 0, 1 is given. Compute T of 4 minus 1, 1 and determine the nullity and rank of T. So in order to obtain the nullity and rank, we have to find the formula for linear transformation. So we have to find the formula for linear transformation means what is T, X, Y, Z. And for that we express X, Y, Z as a linear combination of these three vectors. 1, 0, 0, 0, 1, 0, and 0, 0, 0. So write x, y, z is equal to, suppose x, y, z belongs to R3 be any element. Then x, y, z is what? A 1, 0, x 1, 0, 0 plus b y 0, 0, 1, 0 plus z 0, 0, 1. And then apply t on both sides. T of x, y, z is equal to x t 1, 0, 0 plus y t 0, 1, 0 plus z t 0, 0, 1. And then we write t of 1, 0, 0 as 0, 0, t of 0, 1, 1, 1, and t of 0, 0, 1 as 1 minus 1. And then it is after applying the definition of scalar multiplication and addition, we have b plus c comma b minus c. Obviously this is the element of R square. And so t x y z is what? Y plus z comma y minus z. We have by replacing abc as x y z, we have the formula t x y z is y plus z comma y minus z. And so write this as t x y z is equal to square ax x y z. And what is a 0, 1, 1, 0, 1 minus 1. And then find the rank of a, rank of t and nullity of t as a dimension of base of nullity means dimension of kernel of t and dimension of range of t. So from the matrix A, find the basis and dimension of range of t and kernel of t. So by previous method, and then we have the answer is the rank of t is 2 and nullity of t is 1. Nullity of t is 1 because there are 3 columns, and so rank of t is 2, nullity of t is 1. Their addition is 3. So find the standard matrix for this matrices. Linear transformation, it is R3 to R4. Obviously this R3 means this standard matrix contains 3 rows, 3 columns and 4 rows. So the rank of t plus nullity of t, in this case rank of t plus nullity of t is equal to 3. So addition of rank t and nullity t is 3 because dimension of domain is 3. R3 dimension is 3. So this is the function from t from R square to R raised to 4 be defined by this. We have to write the standard matrix. This is the standard matrix. It contains 2 columns and 4 rows. And so find rank and nullity. Obviously, what is the rank of t plus nullity of t is 2. In this, for this example, rank of t plus nullity of t is 2 because the dimension of R square is 2. So similarly, this is the linear transformation. A is given directly. A is given. Standard matrix is given, and we have to find the kernel of t, null space of t, and nullity of t, and rank of t. Okay, 4th number, right? Rank of t. So find kernel of t as a null space of the matrix A, and a null space of t is the what? Null space of t means the kernel of null space of t. It is not null space of t. Range of t. Find kernel of t and range of t. Right here, range of t, not null space of t. So find basis and dimension of kernel of t. So this is again R3 to R3. So find a standard matrix and then find basis and dimension of kernel of t. So these are also the examples for homework. Find basis and kernel, basis for kernel and range of linear transformation. So these are the linear transformation. Their definitions are given. Write standard matrix and then find basis for range of t and kernel of t. So these are the examples. So these are the standard matrix are given. Find the basis for kernel of t, find rank and nullity of t, find the basis for range of t, find basis for kernel of t. So standard matrix are given. So in the first matrix, in this example, there are 4 columns. So this rank of t plus nullity of t for this first number example is 2. So answers are given. These are the answers. So in each part, find nullity of t. So these are the examples for MCQ type questions. T is from R5 to R7, has rank 3. So rank of t is 3. So what is nullity of t? Rank of t plus nullity of t is equal to dimension of R raised to 5. That is rank of t plus nullity of t is equal to 5. Rank of t is 3. So nullity of t is what? 5 minus rank of t. That is 5 minus 3, that is 2. So answer of first question, A question, is nullity of this linear transformation is 2. Similarly, This is P4. P4. What is the dimension of P4? Is 5. The dimension of P4 is 5. And so rank of T plus nullity of T is equal to 5. And what is the, and therefore nullity of T is what? 5 minus rank of T. That is 5 minus 1. That is answer is 4. Answer of B is 4. Because dimension of P4 is 5. It is not 4. Because P4, what is the standard basis for P4? Is 1x x square, 1x x square, x cube, x raised to 4. That is the set of all polynomials of degree less than or equal to 4. So what is the standard basis for P4? 1x x square, x cube, x raised to 4. These are 5 elements. So dimension of P4 is 5. And so rank of, for this example number 2, rank of T plus nullity of T is equal to dimension of P4, that is 5. And therefore nullity of T is equal to 5 minus rank of T. And rank of T is given 1. So answer of nullity of T is 4. Then R raised to 6 is the R raised to 6 range of T. The range of T, R raised to 6 to R raised to 3 is R cube. R cube means what? Range of T means dimension of RT is R3. And therefore we have the rank of T is 3. And we have to find the nullity of T. The range of T from R raised to 6 to R raised to 3 is R raised to 3. That is the range of T is R raised to 3 itself. And therefore, and the dimension of R raised to 3 is 3. That is the dimension of range of T is 3. Means rank of dimension of range of T is rank of T. So rank of T is 3. We are given indirectly rank of T is 3. Because the range of T is R raised to 3. Means rank of T is 3. And we have to find the nullity of T. So rank of T plus nullity of T is equal to dimension of R raised to 6, that is domain. And R raised to 6 has the dimension 3. And so nullity of T is 6 minus 3. That is 3 answer. The last problem, T from M2 by 2 to M2 by 2. M2 means what? M2 by 2 R. It is the vector space of all 2 by 2 matrices. This is vector space of all 2 by 2 matrices. And has rank 3. And what is the dimension of M2 by 2? Is 4. The dimension of M2 by 2 is 4. M22 is 4. And so for this problem number D, rank of T plus nullity of T is equal to dimension of M22, that is equal to 4. And so, and the rank of T, and therefore nullity of T is equal to 4 minus rank of T, that is 4 minus 3, that is answer of nullity is 1. Okay. So solve all these problems. These problems are also for useful for MCQ type questions. So we will see the remaining examples of rank of T and nullity of T in the next lecture.